Simplification of algebraic fractions. Now in today's part of the lesson, we'll be looking at multiplication and division of algebraic fractions, and also how do we simplify algebraic fractions that involves factorization. Without further ado, let's begin. The first type of simplifications are questions that look like this, where the numbers are expressions without addition or subtraction sign. So when they are just purely factors that's multiplied together, we can do multiplication, cancellation on its own. Right, so for example, the first one, I know many students like to do cancellation of the factors directly, but for me, usually I try not to do cancellation on my paper like that because it's very messy. Instead of that, I will usually multiply the numerator with the numerator, denominator with the denominator. Then I'll use my calculators to do some simplification. So the numbers first, numerator times numerator, 8 times 21, that gives me the number 168. Then I have x squared times y squared, so it'll be x squared y squared. And for my denominator, I have 3 times 16. Alright, then that give me 48. Then I look at my x first, so I have x cubed over here and a y to power 4 over here. But this is not my final answer. Let's simplify using our calculators to cancel out the common factors. So I'll take 168 over 48, and using our calculator, it simplifies to the fraction 7 over 2. Then I'll look at x squared and x cubed. Right, x squared is actually x times x. X cubed is x times x times x. On top there are 2 factors, bottom there are 3 factors. When we cancel, I'll be left with the number 1, and you only have there are more power in the denominator. On top got 2, bottom got 3, so we're left with 1 at the bottom. What about y squared and y to power 4? On top there are 2 power 2, y times y, and bottom there are 4. The denominator has more power, and after cancellation, I'm left with y to the power of 2. Right, have you gotten the answer? Now let's look at the next type of question. What happens if I have a division? So in this case, I'll just need to change the division over here into multiplication, and I'll need to flip the fraction that comes right after the division sign. Alright, so in this case, I will have 8ac over a squared b times ab over 6c squared multiply, then I need to flip this fraction, a over 2b squared. Okay, as my usual working, I will multiply numerator with the numerator and denominator with the denominator. So multiplying across the numbers 8, I have a times a times a, that will give me a to the power of 3, a cubed. Then there's a letter C and a letter B, so it will be B and C. Multiplying the denominator with the denominator numbers first, 6 times 2 gives me 12, right? A squared, no more a, so this will be just a squared. B times b squared, 1 and 2, so total we'll have b to power of 3. C squared, so it's just on its own, right? But this is not the final answer. We remember to simplify. 8 over 12, cancelling out the common factors, will be 2 over 3 using our calculators. A cubed, a squared, there's more power on top. There's 3 and there's 2. Cancelling away 2 of them, I'm left with a. B and b cubed, there's more power in the denominator, right? On top got 1, bottom got 3, cancelling 1 away, I'm left with b to power of 2. C and c squared, so on top got 1, bottom got 2, cancelling 1, so I'm left with 2a over 3b squared c. Alright, so this one will be your answer. So for this type of questions, you notice the expression itself has no addition or subtraction sign. We can simply cancel out the common factors. Now, next type of question. What happens if we have questions of this type where they are expressions of the form involving the addition and subtraction sign? Can we simply cancel out c squared with c, 3d with d, that kind of thing, and numbers with numbers? No, in this case, you should not be able to do that. So I'll tell my students to use my favorite letter, F, and for factorization. Right? You want to factorize each of them into the different factors, the brackets itself. Then we can cancel out the whole factor. Right? So let's do this. There's massive lot of factorization over here. Let's begin with the first pair. 6c squared minus 3cd. The common factor is 3c. Dividing, I get 2c minus d. So the first one over here, that will be 3c bracket 2c minus d. Alright, over. Then this one, second one over here, this is 3cd plus 2d squared. Looking at the common factors, no common factor for the numbers, cd and d squared, so we have a letter d. So this is 3c plus 2d. Right, so this is the factor d, 3c plus 2d. And this one is multiplication. So we have 3c squared plus 2cd. Factorizing the common factor, which is c, I'm left with 3c squared, 3c plus 2d itself. So this is c bracket 3c plus 2d. And last but not least, we have 4c squared minus d squared. You notice that for this type of question, there's no common factors. So we can't factorize by common factor. But what else do we notice? We know that this is something square minus something square. What about 4? 4 is actually 2 square. So in this case, we can use the special product a squared minus b squared to give you a plus b, a minus b. So for this one over here, we will factorize it into an expression with two brackets. One is plus, the other one is minus. So this will be 2c plus d, 2c minus d. Not enough space for working. Then next step over here, for working presentation, we try not to cancel too much, right? In case the teachers could not identify our working. But to highlight what are the factors that we can cancel from the numerator and the denominator, one single pair. So we notice that 3c plus 2d over here has the same factor. So we cancel one from the top, one from the denominator. And 2c minus d, the whole factor is the same top and bottom as well. So then we'll be left with, in my fraction, in the numerator, we have 3c times c. That will give me 3c times c, c squared. And next we have the denominator, d is a factor, and I'm left with the bracket 2c plus d. Right? For simplification of algebraic fractions, do not expand and simplify the denominator. Keep it factorized to show the teacher that you observe there's no other common factors. So this one is my final answer. Have you gotten the answer? Now let's take a look at the last question. Okay, again, this type of question, we notice that we have a lot of different terms in our expression with addition and subtraction sign, right? So we know very clearly we cannot simply just cancel A with A, B with B like that. All right, so we definitely have to do factorization. So I will have 10a minus 5b. The common factor over here is 5. I'm left with 2a minus b. So this one will be 5, 2a minus b. All right. Then next one, what is a minus b whole thing square? A minus b whole thing square, when you have the power 2 over here, it means it's repeated without changing the sign. So it's exactly the same repeated 2 times. So I'll have a minus b, a minus b. Why am I doing this? So that's easier for me to identify common factors, and I can try to divide and cancel away the whole factor and so on. Then next portion over here, what do you notice? We have a division, and therefore we need to swap it to multiplication, and we need to flip the fraction right after the division sign. So I'm going to flip this, do a multiplication. I'm going to flip this. So if that's the case, a square minus b square will be on top, and this is 2a squared plus ab minus b squared, right? But of course we can't cancel it this way, so we'll definitely need to do some good factorization. Just let me write this down. So first one, we have a square minus b square. Obviously, this is our special product. A square minus b square equals to a plus b, a minus b. So we'll have two brackets, two different sign, a, b, a, b. Alright, last but not least, we notice that there is a quadratic expression over here with 3 terms. Probably need to do and try to think of trial and error. This one is a little bit difficult because it's a slightly different type of form, and but we can still use our calculator to help us, just that involves a and b, right? So in this case, we'll look at this. We'll want 2a squared 2a times a to give me a square, and I need a b times b. Alright, so crossing, we have a times b, ab. This will be 2ab. I want a positive ab. Right, so I'll need the larger number to be positive. So 2 minus 1 will give me 1. Then bring over the sign and check negative times positive equals to negative. So therefore this is correct, and we have our answer over in the bracket here. That will be 2a minus b, a plus b. For students who uses the calculator, a will be the number 2, b, the second term will be 1, and this is minus 1, right, negative 1. So using a mode 3-3 or mode 5-2-2, so a is 2, b is 1, c is negative 1, right, because it involves the b square. So I get my calculator. My first answer is 1 over 2. My second answer is negative 1. What does this tells me? Right? This tells me that 1 is with the number 2, 1 is with 2. And since I have the letter a square and b square, so it involves something a and something b. This is positive, so here I'll put a negative sign. And this one is just negative 1, so 1 is on its own, but I have a square and b square, so this will be a and b. Since this is negative, so we'll put a positive here. But of course, in our writing of an expression, we do not need the 1. So in this case, we still get back our factors to a minus b, a plus b. Alright, so I'll show you this away later and use it for later. Now, taking a look at our expression, then we can notice that they are all factorized totally together. Then what we can do, we can start cancellation of factors where there's one pair in the numerator and the denominator. So from here we can see 2a minus b, 2a minus b with 2a minus b, a plus b with a plus b, then a minus b, one pair of it on top and bottom. So technically speaking, we are left with only 5 in our numerator and a minus b in the denominator. Have you gotten your answer? So with that, we'll come to end of this part of the revision. We'll see you for our next video.